In the second half of this module, we'll talk about object-oriented technology a little bit. And of course, most of you guys will probably be familiar with object-oriented languages like C++. So, object-oriented technology is really a software development technique that's expressed in terms of objects and connection between objects. In other words, you're looking at the problem at hand and you break it down into things, in objects that can perform particular tasks and have particular properties or attributes. And of course, you're going to have let these objects interact, communicate with each other. So OOT makes really use of both classes and objects, wherein the class is a really description of the object, tells you what attributes it has, what operations or method it does have, and what kind of relationship it may have with other objects. So an object is really just an instantiation of a class. So it's a logical entity. So I define a class as really kind of a definition and a specification. The object is really the implementation within your program. So a couple of principles we'll talk about the next two slides. But what's interesting is in ee6083, there is actually a supplement called ee6083, which actually talks about object-oriented technology and related techniques. So in a sense, object-oriented technology is now much better. There's a supplement dedicated to it, so there's more access in ee6083 to OOT. So I'm not going to talk into these particular concepts too much, but there's a variety of object-oriented programming concepts like abstraction, the fact that you use classes and objects, encapsulation, the fact that you kind of hide information, which is a good thing, of course, in a lot of cases that we saw before in the source code, but also a bad thing in a sense. Modularity, hierarchy, typing, concurrence, persistent, dispatch. So there's a variety of different concepts. I'm not going to talk about each and every one of them. This is really not a class on object-oriented programming, but some of these concepts are really powerful and make them makes object-oriented technology a very good choice. But there's also some things associated makes it very vulnerable for use in safety-critical applications, like for example dynamic allocation or certain disadvantage of inheritance. Okay, so why consider object-oriented technology? It's very data-centric, so which means it's easy to maintain. Think about it, you define objects and classes. These immediately result in modularity of the code, because you break it down in these objects and these classes, which makes it also much easier to maintain, and also much easier to maintain when the system is pretty large. Now there's actually a lot of object-oriented technology tools like UML, for example, model-driven architectures that are capable currently to generate object-oriented code for you that may be easier to certify. Now besides that, a very simple reason why you want to consider object-oriented technology is because a lot of programmers, a lot of software engineers out there know the object-oriented languages like C++, Java, Ada, 95. Yeah. So all these things are, these languages have object-oriented features. Now, so before this particular object-oriented technology supplement existed, a variety of object-oriented technology issues were already explored at a set of NASA FAA workshops. And actually these handbooks that I have here on the bottom, this reference, I have available on Blackboard. Now key thing is, of course, there is a set of vulnerabilities, especially regarding to inheritance, polymorphisms, overloading, type conversion, exception management, and in my opinion, especially dynamic memory management. There is a ton of different vulnerabilities there which make the use of an object-oriented language, the use of object-oriented technology, maybe not necessarily that suitable for certain safety-critical applications. So what you have to do is you need to make sure that when you use some of these key features, that you somehow can control this vulnerability, that you can make sure, and this can be done very simply. You can easily say, well, this is a feature I'm not going to use, or if I use it, I control it very well. Okay, again, object-oriented. There's a planning phase and a verification phase associated with it. I won't talk too much about this. All right, so if you look at the recommendations, is of course if you're going to use object-oriented technology, make sure to review DO332, and if you're new to it, start with a small, less critical project, and then follow the guidance in 332. Okay? Now, this means that you will have to accept some challenges, because since you are maybe used to the use of all these standard object-oriented features, you have to realize that these features come with associated vulnerabilities. And some recommendations regarding these vulnerabilities are fortunately already given in the handbook for object-oriented technology. I would definitely recommend to go through those. Now, so since you are using this new technology and now the supplement, you want to start work closely together with the certification authorities. Alright, so again, like we saw in the formal methods, in the supplements they specify really a ton of the regular objective like we saw in D178C, but in addition you get a couple of extra objectives that really describe the extra things you need to do with OOT. So now that means that you for example in this case you need to make sure that you verify the local type consistency and verify the use of dynamic memory is robust. I said, and that's what I said before, there's our key features that have vulnerability, so what you need to make sure that you control this. You have to make sure, and it says it here, right, that that's robust. So the dynamic memory management that you're using is robust, and that you can guarantee that it may not result in any problems.